First of all, I wanted to start from the introduction, who is Hewlett Packard Enterprise, because I found that actually almost no one, especially from the young people, don't know company Hewlett Packard Enterprise. Otherwise, Hewlett Packard Enterprise is quite big and well known in the area of high performance computing and AI at scale. And also, we have very good tools which can help you to make your job developing machine learning models and training them. So actually, the Hewlett Packard Enterprise company was created based on the split of the Hewlett Packard company about 10 years ago. There was a big company called Hewlett Packard, which was probably the largest IT company in the world those time. And because it was very complex to manage, that was actually the official explanation why the company was split, so I don't know the real one. So the company was divided to several organizations. And the organization which take cares about enterprise-grade hardware infrastructures was Hewlett Packard Enterprise. Actually, before the company was split, we owned one of the most advanced AI companies in the world, which was Autonomy, if someone remember. But what is interesting, actually, in several years after we bought the company Autonomy for quite a big money those time, deep learning networks appeared. And everything we bought was just, I cannot tell it was for nothing, but actually it's like this, right? So you spend $10 billion, and then in 3 years you realize you just a student in the university can do much better job, probably for $1,000. That was the beginning of our story in artificial intelligence world. But then when we became Hewlett Packard Enterprise, and we start combining different technologies together with what we developed in our labs. And we bought company SGI, then we bought company Cray, and several software companies. Because for larger companies, it's much easier, and probably the right way to have the portfolio of products is just to buy some company which is already successful. Because it's already proven way, right? And we have money for that, so we use it somehow. So if you make very good company for machine learning, let's say, tools, maybe you can come to us and we buy your company, you earn a lot of money. So currently, we have quite good portfolio, but let's come to the story. I hear a lot about cloud in machine learning conferences. But if you take a look on high performance computing world, where originally I came from, and actually with this high performance computing, we currently do a lot of job for AI, for large models. Because currently, when you work with large models, when you train them, you actually need large machines, right? And you will find very interesting situations that in the cloud, there is quite a small amount of installations because of different reasons, starting from compliance and finishing just with very simple topics that you need to ingest data and to get this data back. Yeah, for some projects, maybe it's not critical, but finally in enterprise, you mostly find that people use on-premise installations. Not for everything, but very often for large-scale solutions, it's on-premise. We also have our own cloud because we purely understand that cloud is a convenient way for some other part of application, and as you saw on previous slides, still up to 30% in some industries where it comes about high-performance computing, including AI at scale, people are in the cloud. Okay, so good market. So we also developed our cloud, which is in contrast with traditional capacity clouds, is a capability cloud. So it's actually a supercomputer behind. So that means if you want to solve a big problem, you can do it much better in our cloud than, let's say, in the competitors' clouds. Because we have very good competences in building large machines, and actually the largest machines and the most powerful in the world are built by our company. Okay, shortly about hardware, just a few slides. So We have a lot of servers which you can use. We build based on these servers supercomputing machines. Here is just some examples of the machines which are the most popular probably for high performance computing and AI at scale. The first machine, that's you can install in a single rack 100, and there is an option for 200 dual CPU servers. If you know how to build these supercomputing machines, how much of space you require to put a server, you probably understand that 100 or 200 dual CPU servers in a single rack, it's quite a lot, right? Or you can have 32 terabytes of memory. Why do you need it? Why do you need a lot of memory in machine learning? Do you see any applications where you need a lot of memory? What? Genomics. Very good type of applications, right? In genomics it happens, especially when it's about genomics which is not a human genome, but when it comes about wheat genome, you know, the other genomes, especially for wheat, they're quite complex. So you need a lot of memory to solve the problem. But also, if you are solving graph problems, if you have graph analytics, big memory also can be a big help. And then comes some traditional stuff with GPU, which are quite popular today. That we often use, you know, NVIDIA GPU, which is definitely the most popular GPU today. And we have a lot of storage systems, which are another part of the story, which often is not taken into account when you design the infrastructure, and that's a big problem. Because very often a storage system influences the performance of high-performance infrastructures significantly. Just a simple example. Recently, one financial customer doing analytics with some tools. If I'm not wrong, they were using SaaS tools. There is a company called SaaS, right, which makes analytical tools for finance. And they asked us to help with the performance tuning. One of the jobs we do for our customers, let's say you have your system and you have your applications, but you want to run them faster. We often do an exercise which is called performance tuning. We help to reconstruct, to fine-tune the system to run it faster. So finally, we were able to increase the performance of the system more than 10 times. It's about like 14.5 times. Only fine-tuning the input-output to the storage and slightly changes the storage infrastructure. So you imagine just making a small change, you are having more than 10 times performance increase. But for today, we found that to be successful not only on this large supercomputers market, but also for some smaller scale. And smaller scale today is very interesting. You know, if you want to train some big models and you buy a small single server with the modern GPU of NVIDIA, it can cost $1 million or $500,000 a single server. So it's quite a good small scale, even for us, right? So we found that to be better present on this market of small scale installations, we need to have better middleware, a software which will help you to build, develop, and train your models. And we understand that there are several important things for organizations which are interested in the tools we do. It's mostly some corporations and governments. And the first, probably the most important, is to make your AI responsible. It definitely depends on what applications you are building, which kind of applications you are building. If you are making some video games, probably the risk of making not very responsible AI is not big. You just can lose some money. But if you make your autonomous car driving wrong way, you can kill people. That's a problem, right? And when talking about responsible AI, we believe that two important points should be realized should be made. First of all, this AI should be reproducible, and second, it should be explainable. So reproducible means that you should exactly know which data you used, how you transform them, which procedures you run on this data, and you should be able to repeat all the workflow starting from the beginning, and if possible, with some single operation, just pressing one button. And it also should be explainable AI, which, let's say, for some inference result which you're having, you should be able to find out easily why your model gave these results. So based on these principles, we actually build the systems, the software, the middleware, which we deliver to enterprise market for today. And we also solving the problems of flexibility, scalability, and reproducibility. So when we talk about flexibility, it means that you can run our software roughly everywhere. You can run it on-premise, you can run it on cloud. You can run it using simple CPUs, or maybe NVIDIA GPUs, or maybe you want to run on AMD GPUs, or maybe Intel GPUs. So they are fully heterogeneous, and they are flexible also in terms that they are good tools for different personas inside of your organization. And also they are scalable. Scalable because, first of all, we are solving the problem of making the tools optimal for your organizations, for enterprise, first of all, to make it efficient. So when you want to solve your problem faster, you should be able to run, let's call it parallel training, parallel supercomputing training, and you should be able to automate everything to spend humans' time less. You know, that people work less but have more results, because probably, maybe you, as a data scientist, you should not spend your time managing your hardware infrastructure. Or maybe, you know, being data scientist, you only want to focus on which knowledge you should extract from data, but don't think about some underlying algorithms. And actually, we found that, yes, our tools are interested for the market, and we have quite big amount of customers already for today in healthcare, in military, autonomous driving. One of the interesting cases from recent years is implementation of the system for Zenzact. Zenzact is Volvo department, or let's say a company which somehow belongs to Volvo, but which is making a software for autonomous driving. So the main problem for Zenzact was to collect the data and to prepare the data for training. Because actually, when they run these autonomous cars, they collect from each car terabytes of data per day, for several hours while the car is driving and collecting this data. And finally, they end up, at the end of the day, having a lot of cars driving on the street with huge amount of data, which is impossible to transfer online through the wireless networks. So the question was how to make it, how to collect this data. That was the major problem, which was definitely solved. And the other problem was more a functional problem. They wanted to have end-to-end versioning and end-to-end lineage to understand exactly how the model was trained, which data the models was using. Because if something happens on the street, which is bringing troubles for them, they should be able to track back and to reconstruct, to change their models, to find out because of which data this could happen. And that was one of the key problems they were solving with us. Okay, so when we work on our tools, when we build our portfolio of tools for machine learning, we actually build it understanding different stages of pipeline. Here is a classical data analytics AI ML pipeline, how we see it for today. Below are different tools, mostly open source, which are used on the market. And depending on the exact workload you're solving, you will focus either on first, second, or maybe the last part of this workflow, of this pipeline. The first set of the tools we have is called Ezmeral. These Ezmeral software tools, they have two major components today. One is called Ezmeral Data Fabric. Another is called Ezmeral Unified Analytics. What are these components? The Ezmeral Data Fabric software is actually a software-defined storage. It is a storage system which is built based on the standard servers, can use the same servers which are doing processing. And the major benefits and features of these storage systems are that it's multi-protocol. So let's say working with your data in organization and building your model, you start from streaming the data. You need to support streaming. It's a specific workflow, sometimes requiring specific protocols to access the storage data. Then you want to transform your data, maybe using HDFS-IP. Then maybe you want to run Spark using some POSIX protocol. Or maybe S3 protocol you need for some other tools like Pachyderm. And then you want to run some model training where you also need some POSIX or NFS. What you typically do in organization? If you have a small project, you don't care, you have everything on your computer. You always have a block access, it works with everything, roughly. But if you have a big infrastructure, usually you start copying. You copy the data to another storage, or you add some gateway to access the data via different protocol. And that's a problem. It takes time, it takes money. So this storage allows you to access all the data from all the protocols you need. It's roughly, definitely there are technical specifications which you should read and understand where it works, where it doesn't work, right? And it also a good system which supports a single namespace of all the installations you have. Let's say you have a big organization which has presence in all the world. You have also installations in cloud, in premise, something in New York, something in Warsaw, and you want to have a single namespace. Because you don't want to make too much copies of your data, and you really want to know which data you have. And this system supports a single namespace across all your installations of this type of software storage. Okay, the other part, which is called Ezmeral Unified Analytics, is actually a set of different open source tools, which are usually used by data scientists or data engineers or analytical teams, but with commercial support from Hewlett Packard Enterprise. So that's important definitely for enterprises, first of all, or for government organizations. For personal use, it definitely doesn't have sense, right? And we also have a set of tools for the problem which we call AI at scale, but actually it's just a training and development of your models when they need scale, when you need to make something big. Here we have 4 major tools. 2 of them are used most often, and 2 others are like solving specific problems. So first 2 tools are machine learning data management, and another tool is machine learning development environment. They are focused exactly on data management and pipeline building, and also on training of the big models. And the tools Smart Sim and Swarm Learning, which do some slightly different job. I will tell you a little bit more later. Okay, so machine learning data management, what this tool does for you. Anyone heard about a tool called Pachyderm? No one. Oh, why we bought this company? No one knows about it. Okay. Actually, oh, you know Pachyderm. 5 minutes. I think you know Pachyderm, sorry. Okay. So Pachyderm is open source version of machine learning data management. If you want to use it for free, you go to pachyderm.org or .com, don't remember. You can check, and it's available. It's actually about managing the pipeline and ensuring about data lineage, which is necessary for compliance, most of all, but also for your understanding how this final model was created and to be able to reproduce all the results which probably maybe were built by your colleagues in a big team. And the next tool, once we have not much time, so I will not stop too much on each of the tools, is called machine learning development environment, which also has open source version, which is called Determined AI. Maybe someone heard about Determined AI? No. Everyone lives in the cloud. Yeah. So this tool is used for several key problems. One of them is parallel computing, let's say supercomputing training of the model using model parallelism feature, first of all. And this tool does very good job, probably one of the best in distributed, or let's say, supercomputing training. So if you need to train large models, that's something you really can benefit from. It also helps you to make hyperparameter search, actually using the standard algorithms. They are available on open source, but it's just very convenient to have it built in the tool. It's made a kind of automatic way, very simple, very useful. The other feature is checkpointing. So when you're making your job, you will have always checkpoints, so you can always find the state of the system, which was the best for you. You can set up the parameters which you are looking for, what is the most important for you, and it will just leave the checkpoints which is the most useful, and will delete all the others. It also does deduplication, and it also does a feature which allows you, which we called interruptibility. You can stop your experiment. Let's say you do some training which is very long and which, I don't know, takes a week. You can make a snapshot. You can stop the system, run some other tasks which you want, and in a week or after you find out something important for you, to continue training. A few words about SmartSim and swarm learning. So SmartSim is a tool which allows you to connect your code written on C, C++, Fortran with AI, ML, modern type of codes. So actually, if you want to combine your simulation and modeling applications and analyze the data or visualize the data using your ML AI tools, usually what you do, after making simulation and modeling, you save the data on storage, then you read the results with your ML AI tools and analyze them. It works. But what we do, we allow you to make it online. You make calls via special libraries online, and that really saves time and make it much easier to analyze your data. And swarm learning is a tool which somehow resembles federated learning. So I guess federated learning, definitely everyone heard about it, so knows what it is. But the difference here with federated learning is that it doesn't have a dedicated leader. And it can be very useful in some situations where, because of some political or administrative restrictions, you cannot have a dedicated leader. We found this very important for some medical networks of organizations and also some financial organizations. Even inside of the organizations, it's interesting, but some financial organizations inside of one organization cannot sometimes share the data between the departments, but they want to share the knowledge. And how we can share the knowledge? Training the model using all the data, but without exchanging the data. Only exchanging hyperparameters and parameters of the model and merging them. So that's where we use this tool. Thank you very much for listening. I hope you will like some of our tools. You're welcome to use them. They are available in open source and they are available in commercial versions. You're welcome.
Thank you.